We are now in the first example of 2.5 day 2. We've been talking a lot about finding zeros and doing factorizations. We're going to take a slightly different approach in this case when we're given different information. So we're going to find all the zeros as we did before and write the linear factorization, but we're going to do so with some different information. They're going to give us the fact here that one of the zeros is 1 plus 3i. It follows from that that one of the other zeros is 1 minus 3i because, like we've mentioned, imaginaries always come in pairs. So we're going to use these two zeros to hopefully give us the rest of the zeros without actually going through the same process as usual. We're going to do this without a calculator. So one thing I want you to remember about these, when you see these types of problems in your homework, is you should try to do these without a calculator. On the upcoming test, I will be requiring you to do this without a calculator, and the whole idea is that we have other information that will get us there a little bit more efficiently. So we've got these two zeros. Notice that it's x to the fourth. We are going to find a total of 4 because that's what the degree implies. But we're going to start by just getting rid of these two. We're going to divide them out of the original one by synthetic division. It's kind of interesting that you can use synthetic division in the same way with imaginaries. So this is going to be our k value because that's the 0, so we just start the process as normal. Synthetic division, we bring the 1 down. We're going to multiply by 1 plus 3i. Anything times 1 is itself, and so we have 1 plus 3i as what we get after multiplying. Now here's the weird thing about this. Now we're going to add this together, keeping in mind we add like terms. So the negative 2 and the 1 will combine, but the 3i is just going to be as is. So we're going to do negative 2 plus 1, and that's negative 1, and then we still have plus 3i. All right, so we have an interesting thing show up in our synthetic division. Now, like usual with synthetic division, we take this and we multiply it by this. Now you'll notice that I have this sidebar here, I have this dotted line, and I would encourage you to do the same when you're doing these kind of homework problems. Is we're going to multiply this one by this one, but we actually have to FOIL it. So that's why I'm going to give myself a little bit extra space. I'm going to multiply this by negative 1 plus 3i. Now, the great thing about this is it's going to turn out really nice. So we have 1 times negative 1 is negative 1. 1 times 3i is 3i. 3i times negative 1 is minus 3i. And then 3i times 3i is plus 9i squared. So what you'll notice about this one, most likely, is that we get those 3i's to cancel out. The middle term's gone. 9i squared is the same thing as negative 9. So now if we put those together, we've got negative 1 minus 9, so that's equal to negative 10 for that portion. So now I can go back up here, fill in negative 10 to my synthetic division. Now I continue on as normal. 5 minus 10 is negative 5. Now I do negative 5 times I plus 1 plus 3i, so I'm just distributing that in, and so now I'm going to have negative 5 minus 15i. I'm trying to fit that in here, it's a little difficult at this point. And then I'm going to add these together. Remember, like terms together, so 10 minus 5 is 5, so it'll be 5 minus 15i in that portion. Now what's left over here is going to be the 0. But let's just make sure that we expect this times this to be 50 so that there's a 0 remainder, but let's just make sure, let's actually go through that process. So 1 plus 3i times 5 minus 15i. So 1 times 5 is 5. 1 times negative 15i is negative 15i. 3i times 5 is plus 15i. 3i times negative 15i is going to be negative 45i squared. So like last time, the middle terms cancel. That's a nice thing. This term right here becomes plus 45. We have 5 plus 45, that equals 50, and so now we've got 50 here, and we can have a 0 remainder, and that's a good thing. That tells us that this actually is a 0. We've verified that now. We also, though, have to do another step of synthetic division with this one. So now, if you've had fun with the first one, you get more of it in this second one, but the good news is that this one's going to be a lot easier. Well, we're going to just go right off of the result from the old one, and we'll have 1 minus 3i out here. So same process. We bring down the 1. Multiply this by 1, so then we've got 1 minus 3i. Take a look here. This is where the second step is a lot easier. Those are just going to cancel out to 0. Anything times 0 is 0. And so then negative 5 plus 0 is negative 5. And now negative 5 times this, we distribute it, and we get negative 5 plus 15i. And notice again that those cancel out. And so this is just going to be 0. So now that we have that, that's a lot nicer thing to work with. We can finish out this problem knowing that, well, this is our remaining quadratic. So what this represents, this 1, 0, negative 5, since we've taken a 4th degree polynomial and we've cut it down twice, that means that we're dealing with x squared minus 5 as our remaining quadratic. So now we need to figure out what zeros come from that. Now it's a quadratic, so we could do factoring or we could do quadratic formula, but notice in this case that we just have a really simple one. It's just x squared minus 5. If we set that equal to 0, we'll be able to find out what makes that 0, what makes the other zeros in this case. So we add the 5, x squared equals 5. Take the square root of both sides, oops, not x squared, but x equals plus minus, don't forget about that part, square root of 5. So we've got that as our other two zeros. Now, we've got all 4 zeros at this point. We have the plus minus square root of 5. Those are both real. We have 2 imaginaries. And so the final piece of this process is to write out the linear factorization. F of x equals x minus square root of 5, x plus square root of 5. Then we use our imaginaries, x minus 1 plus 3i, and x minus 1 minus 3i. And that's getting way off the page there. Hopefully you can still see that. And that's our linear factorization. So to recap what we've done in this problem, we started off with this polynomial that we were given a 0. We knew that had to partner with it. We took those out with synthetic division, eventually got down to a quadratic, directly solved that quadratic for our real numbers, and then wrote it out with our linear factorization.